Welcome to Skillzam, a cure platform, cross-skill, upskill, reskill, and expert skill. We are your best learning partner for life. Skillzam, keep learning. Hello and welcome to the Skillzam course on computer basics. I'm really happy to welcome you to this exciting course which will take you from knowing nothing about computers to getting familiarized to the world of computers. Computers are everywhere in your pockets in the form of mobile phones or on your wrists as a watch, in the toys that your kids play, at your office, at your favorite restaurant you visit. You name a place, they are bound to be there. This fundamental course, in my opinion, is the best way to get introduced to the computers and their underlying technology. Rightly so, you have come to the right place. Computer basics. Now, before we start learning, let's take a couple of minutes to get quick overview of how the course is organized so that you know exactly what to expect. So the course contains about 7 sections, and we are going to kick off the course with knowing a brief history of computing, like how did it all begin in the first place. Then you will learn fundamentals of binary number, because everything that computer understands is binary, either zeros or ones. After that, we will understand how an electricity is converted to bits. Then, moving on and making a deep dive into the digital logic gates like AND gate, OR gate, and so on. This will be followed by bits and bytes, as we have heard many a times from our dear ones saying, "My mobile phone is almost full. I'm just left with 20 MB space." Here we'll understand what is this unit of information called MB and other details. With having understood all the foundation, it is now the time to know more about computers, like what is a computer, followed by the last topic of the course, major components of a computers. That is, you will understand what makes a computer a computer. Well, we have included everything you need to know about computer basics. Alright, so I hope that you are going to have a lot of fun with this course. And with that being said, let's finally get started. Welcome to the Skillzam course on history of computing. In this section, you will start learning the brief history of computing, like how did it all begin in the first place. In order to understand modern computers of today, we first need to know how did humans start the computation. Later, what technological innovations and discoveries have led to the formation of computers that we see today. Ishango bone, as the name suggests, it's a bone tool and possibly mathematical object dated to the Upper Paleolithic era. It was discovered in the area of Ishango near the Semliki River, which is now in the border between modern-day Uganda and Democratic Republic of Congo. It is a dark brown length of a bone, the fibula of a baboon, with a sharp piece of quartz affixed to the one end, perhaps for engraving. It is thought by many to be a tally stick, as it has a series of what has been interpreted as tally marks carved in 3 columns running the length of the tool, though it has been suggested that scratches might have been to create a better grip on the handle or for some other non-mathematical reasons. The artifact was estimated to be originated more than 20,000 years old, somewhere between 18,000 BC to 20,000 BC. Suanpan. The abacus was initially used for arithmetic tasks. The Roman abacus was developed from devices used in Babylonia as early as 2400 BC. Suanpan is an abacus of Chinese origin, first described in 190 AD Book of Eastern Han Dynasty, written by Zhu. Usually, a Suanpan is about 20 centimeters tall and it comes in various widths depending on the application. It usually has more than 7 rods. There are 2 beads on each rod in the upper deck and 5 beads on each rod in the bottom deck. The beads are usually rounded and made of hard wood. The beads are counted by moving them up or down towards the beam. The 2 types of beads on Suanpan: the lower deck beads, also called earth beads or water beads, and carry a value of 1 in their column. The upper deck beads are also called heaven beads and carry a value of 5 in their column. Suanpan can be used for functions other than counting. Like very efficient Suanpan techniques have been developed to do multiplication, division, addition, subtraction, square roots and cube roots operation at high speed. Antikythera mechanism. This is basically the first non-human computer by any time. Antikythera mechanism is ancient Greek. Obviously this is a Greek discovery, and it was a hand-powered orrery described as the oldest example of analog computer used to predict the astronomical positions and eclipses decades in advance. So this instrument is believed to have been designed and constructed by Greek scientists and has been variously dated to somewhere around 87 BC, or some historians predict it to be 150 to 100 BC, or some say it is way earlier than 205 BC. And what are these uses of Antikythera mechanism? Basically, it was used to track the 4-year cycle of athletic games, which was similar to an Olympiad, the cycle of ancient Olympic Games. This artifact was among wreckage retrieved from a shipwreck off the coast of Greek island Antikythera in 1901. Antikythera mechanism, like if you can see on your left, shows a picture of Derek Price with a reconstructed model of Antikythera mechanism. So as you can see, ancient history involves a lot of innovations and inventions and discoveries that helped and aided the human computing history. So many of the mechanical aids to calculation and measurements were constructed for astronomical and navigation use throughout. So one of those brilliant minds of old times was Abu Ryan al-Biruni, who was around 1000 AD, invented the first mechanical geared lunisolar calendar, astrolabe, an early fixed-wired knowledge processing machine with a gear train and gear wheels. Napier's bones. Let's now enter into the industrial age, which is 1600 AD. John Napier, a Scottish nobleman and a politician, devoted much of his leisure time to the study of mathematics. He was especially interested in devising ways to aid computation. His greatest contribution was invention of logarithms. So what he did is he inscribed the logarithmic measurements on a set of 10 wooden rods, and thus was able to do multiplication and division by matching up the numbers on the rods. These became known as Napier's bones. Napier's bone is nothing but a manually operated calculating device, and the method was based on lattice multiplication and also called rhabdology. The slide rule, William Outred. The slide rule was invented around 1620 to 1630 AD, shortly after John Napier's publication of the concept of logarithms. In 1620, Edmund Gunter of Oxford developed a a calculating device with a single logarithmic scale. With additional measuring tools, it could be used to multiply and divide. So in 1622 AD, William Oughtred of Cambridge combined two handheld Gunter rules to make a device that is recognizably the modern slide rule. This calculating machine, which was used until mid 1970s, so it gone through centuries when the first held handheld calculators and microcomputers arrived. So right from 1622 to 1970, slide rule was the device that ruled the computation. Let's enter the programmable machine world. So it was a Jacquard loom. It took inventor Joseph M. Jacquard to bring together Bouchon's idea of continuous punched roll and Falcon's idea of durable punched cards to produce a workable, programmable loom. So the weaving operations were controlled by Jacquard machine, a device fitted to a loom that simplifies the process of manufacturing textiles with such complex patterns. The machine utilized punched cards tied together to form a long loop or chain, and you could add as many cards as you want. Each time a thread was woven in, the roll was clicked forward by one card. This results revolutionized the weaving industry and made a lot of money for Jacquard. This idea of punched data storage was later adapted for computer data input. The father of modern computers, Charles Babbage, but the irony is none of his computers worked or even constructed in their entirety. He was first designed plans to build what is called the automatic difference machine. It was designed to help in construction of mathematical tables for navigation. Unfortunately, engineering limitations of his time made it impossible for the computer to be built. While being a professor of mathematics at Cambridge University, he proposed the construction of a machine he called the analytic engine. It was to have a punched card input, a memory unit called the store, the arithmetic unit called the mill, automatic printout, sequential program control, and 20-place decimal accuracy, making it the first design for general purpose computer, a Turing complete. He had actually worked out a plan for a computer 100 years ahead of his time. Unfortunately, it was never completed. It had to wait for manufacturing technology to catch up to his ideas. Babbage is credited with inventing the first mechanical computer, the difference engine. Colossus computer, 1943-1945 AD. The first really successful electronic computer was built in Bletchley Park, England. It was capable of performing only one function, that was of code breaking during World War II. Colossus computer is regarded as the world's first programmable electronic digital computer, although it was programmed by switches and plugs and not by a stored program, and it could never be reprogrammed as well. So Colossus were used to help decipher intercepted radio teleprinter messages. Mark I, 1944 AD. In 1944, Dr. Howard Aiken of Harvard University finished the construction of automatic sequence controlled calculator, also popularly known as Mark I. It contained over 3,000 mechanical relays and was the first electromechanical computer capable of making logical decisions like If suppose x equal to 3, then do this. If x equal to 5, do the other thing. So it could perform an addition in 3/10 of a second. I mean, if you compare that to a couple of nanoseconds of today. The important contribution of this machine was that it was programmed by means of punched paper tapes, and the instructions could be altered. So in many ways, Mark I was a realization of Charles Babbage's dream. ENIAC 1946 AD. So this year saw the birth of the first all-electronic computer called ENIAC, which stands for Electrical Numerical Integrator and Calculator. It was designed by Presper Eckert and John W. Mosley of Moore School of Engineering at the University of Pennsylvania. ENIAC was the first multipurpose all-electronic computer, though very difficult to reprogram. It was primarily used to computer aircraft courses, shell trajectories, and to break the codes during World War II. Just to give you the size of ENIAC, it occupied around 20 by 40 foot room and contains around 18,000 vacuum tubes. ENIAC could never be turned off. So if it was to be turned on, it blew too many tubes. It had a very limited storage capacity, and it was programmed by jumper wires plugged into a large board. The transistors. In 1948, an event occurred that was to forever change the course of computers and electronics. Working at Bell Labs, three scientists, John Bowden, Walter Brattain, and William Shockley, invented the transistors. The transistor is a semiconductor device used to amplify or switch signals and electrical power. Now, what's the question that flashes mind is, what is a semiconductor? Well, a semiconductor material has an electrical conductivity value falling between that of a conductor such as a metallic copper and an insulator such as glass. Its resistivity falls as its temperature rises, like the metals behave in an opposite way. Because the controlled output power can be higher than the controlling input power, the transistor can amplify a signal. Hence, transistor became a building block of modern electronics. The change over from vacuum tube circuits to transistor circuits occurred between 1956 and 59 AD. This brought in the second generation of computers, those based on transistors. The first generation, whereas it was a mechanical and vacuum tube computers. UNIVAC and IBM 650. The first practical electronic computer, UNIVAC, which stands for Universal Automatic Computer, was built by Eckert and Mosley, the same two geniuses who built the first electronic computer known as ENIAC. This UNIVAC was used by Bureau of Census. The unique feature of UNIVAC was that it was not a one-of-a-kind computer, rather it was produced in mass. Now let us understand IBM 650. In 1954, the first electronic computer for business was installed at General Electric Appliance Park in Louisville, Kentucky. This year also saw the beginning of operation of IBM 650 in Boston as well. This comparatively inexpensive computer gave IBM the lead in the computer market. Over 1,000 IBM 650s were sold. It was a big commercial hit. Many more innovations followed. In 1965, the first integrated circuit computer, the PDP-8, which stands for Programmable Data Processor, from Digital Equipment Corporation appeared. After this, the real revolution in computer cost and size began. Intel Corporation revolutionized the CPU or the processor industry. It produced the first microprocessor chip in 1971, which was 4-bit chip. Today's chips are 64-bit, just a comparison. At approximately 1 by 16 into 1 by 8 inches in size, this chip contained 250 transistors and had all the computing power of ENIAC. It matched IBM computers of the early 60s that had a CPU the size of an office desk. The Altair 8800, the first low-cost microprocessor computer, was featured in 1975 issue of Popular Electronics article. Apple was not left behind. In the late 70s, Steve Jobs along with Steve Wozniak built the most successful of the early microcomputers, the Apple II. Steve Wozniak with his fellow business-savvy friend Steve Jobs, they started Apple Computer in 1977 in Woz garage. Less than 3 years later, the company earned over $100 million. Not bad at all for a couple of college dropout computer geeks. Comparisons with ENIAC, faster, better, cheaper. As we know, ENIAC was the first all-electronic general-purpose computer built in 1946. If we compare it with the computers of 90s, they were much better, faster and cheaper. 36,000 times faster, better memory capacity of 1,000 to 5,000 times larger, 1 by 30,000 the size, 1 by 30,000 as much in comparable dollars. As we compare the same ENIAC with the computers of 2000s, 180k times faster, memory capacity 25,000 times larger, 1 by 30,000 the size, 1 by 60,000 as much in comparable dollars. So it's really astonishing to compare the computers of today with the past. They are much faster, much better and much cheaper, thereby elevating the standard of living. Ultra advanced computers. The computers of today are available in pockets, on the wrists and even on the fingers to be worn. These devices are nothing but computers of advanced technology. Like for example, early mobile phones utilized GSM, which is Global System for Mobile Communication, a standard developed by European Telecommunication Standards Institute to describe the protocols for 2G, that is second generation digital cellular networks used by mobile devices such as mobile phones and tablets. It was first deployed in Finland in December 1991. Now we have entered 5G protocol for the better implementation of IoT, that is Internet of Things. Smart watches like Apple Watch or Fitbit watches are also a computer in itself that make use of Bluetooth technology along with photoplethysmography, that is PPG technology, to record heart rate from the surface of the skin, that is wrist. This method eliminates the need for a chest strap. The PPG shines light on the screen. The optical sensor measures the reflection of the light. The heart rate is determined by measuring how much blood passes through the illuminated spot as the heart beats. Next is the smart rings are disrupting the financial industry in its own way. The inventors of the smart rings, Napier, catalyzed the smart ring industry in 2013 with the NFC technology. Well, what is a smart ring? It is a wearable electronic device with advanced mobile components that combine features of mobile devices with innovative measures and features useful for mobile and handheld use. One of the main features of the smart rings is to serve as a near field communication, that is NFC device, effectively eliminating the need to carry credit cards, key doors, and car keys, and potentially even ID cards or a driver's license. So let us understand more about NFC. So NFC is nothing but near field communication, is a set of communication protocols for communication between the two electronic devices over a distance of 4 centimeters or less. With this, we come to an end of history of computing section. These advancements in technology and computation are helping us enter the world of space, to land on Mars, to make a reality of having a driverless car, flying drones, or for that matter, even the fastest and faster creation of COVID vaccine. In every effort, the computers are aiding the human race. So thank you for learning with Skillzam, and never stop learning.